We got to keep the noise down so I can record my video. Ignore me if you know this already. We're going to go on the adventure of side chains now. What we're looking at here is a CH3 hanging off one of the main chains. So we've got 1, 2, 3, 4, 5 carbons. So that's going to be methane, ethane, propane, butane. And we've got one carbon group hanging off it. When you've got a carbon group hanging off it, this is what we call a methyl group. It's not methyl, it's methyl. Now when we look at this, we're going to go, well, this is going to be carbon number 1 because that's the carbon that the methyl group is closest to. So as a result, we're going to go, well, this is carbon number 2 that it's on. So it's going to be 2-methyl, 1, 2, 3, 4, 5, pentane. 2-methyl pentane. And that tells us that the methyl group is on carbon number 2. You could stick the carbon here, but now it's no longer pentane. It's hexane, because you can go across and you just see it's another carbon in the chain. So you've got to be careful that you're not being tricked in that kind of scenario. You also need to be able to draw it in stick form. So methane, ethane, propane, butane, pentane, and then the ethyl group is going to look like a stick coming off there. There's carbon 1, 2, 3, 4, 5. Certainly a lot easier to draw like that than that. Okay, here we've got 1, 2, 3, 4, 5, 6, 7. So that's going to be heptane. And we've got 2 carbons hanging off it at carbon number 3. So that's going to be 3, and it's called an ethyl group. Not ethyl, ethyl, heptane. And if I was to draw it in stick form, 1, 2, 3, 4, 5, 6, 7, and it's on carbon number 3. So it's going to be 1, 2. So this is 3 ethyl, not ethyl, heptane. You're doing it to shit me, I know it. They're not methyl groups, not ethyl groups. Alright, what do we got here? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. So octane. So it's going to be 3 propyl octane. And there's no space between those two words there. 3 propyl octane. So propyl is what we refer to as a 3 group. Uh-oh, looks like I'm wrong. See, you've got to watch out for the tricky bits. How about if I counted it this way? 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, if you looked at the carbon chain, it goes this way and down. That's the longest chain there. So we're not looking at 3 propyl octane. We are looking at 1, 2, 3, 4 ethyl nonane. So you've got to be a bit careful. Make sure that you count the carbon chain that's the longest. You see, if you look at the 3 ethyl heptane here, you could go 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Either way, you're getting heptane out of it. Doesn't matter which way you've got the chain going, and either way you're going to get your ethyl group out of it. Whereas this one here can be read a couple of ways. It can either be read along here, or it can be read up and across. And the deal is that you have to read the longest chain. And if that means going up and across like that, well, then that's what you have to do. See, the thing is, these single bonds here, they can rotate in 3D space. They're actually quite flexible. And so these molecules can bend. It can happen. So, in summary, 1 carbon hanging off the chain is a methyl. 2 carbons is an ethyl. 3 carbons is a propyl. But what happens when you introduce a nice big structure? Let's say, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got decane here. And we've got 1, 2 ethyl groups there. We're going to start from carbon number 1 here, because the methyl groups, are this close. And it's going to be 1, 2, 3. So I'll number them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we've got two methyl groups here, which is going to be this one here and this one here. So you need to indicate that you've got two of them. And they're on carbons 3 and 4. So it looks like this. 3, 4 dash dimethyl decane. 3, 4 dimethyl decane. And when you're dealing with more than one of one particular thing, you've got mono, normally you don't have to use that, di, tri, tetra, and penta. So 1, 2, 3, 4, 5. That's what these mean. So here we've got a dimethyl. I could add another one and put it there. 1, so 3, 4, 7 dash trimethyl decane. So now I've added 3. The commas and the dashes are important. It's all part of the EIU pack nomenclature. Why don't I make it even more complicated? Let's draw up another decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's put a double bond. Not happy with that. Need to straight along. Let's put a double bond here, and then we'll do our two methyl groups here and here again. Now we can count from two sides. This side or this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you've got a double or a triple bond in the primary carbon chain, that actually changes where carbon number 1 is. So rather than starting from the end where the methyls are, we're going to start from here because the double bond is closest to this end. If there was a triple bond, it would be the same. So when you've got a double or a triple bond, that's going to become carbon number 1. I could move that double bond to there, would still be counting from this one here because that's the closest end. So now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we're going to be naming it from carbon number 1, it's going to be 7, well, that's a crappy 8. I'll do 7, 8 dash dimethyl dec dash 2 dash ene. Remembering that ene indicates the double bond, and we're seeing that the double bond starts from carbon number 2 to carbon number 3. Of course, it could start from carbon number 1 or carbon number 3. You just change the numbers over to suit. But because we're going from 2 to 3, it's going to be 7, 8 dash dimethyl dec dash 2 dash ene. Thank you.
So you fix up
Is that alright with this?
Yeah.
Yeah, okay, good.
So you fix up a 6. It looks like 0.
Where?
Oh, it does.
Oh, what? That's the worst 6 I've ever done. There you go, how's that? Better? Yeah.